Hello all, I am Prarthana JV, handling microcontroller laboratory. Here in this video, I am just giving you the glimpses of the software that we'll be using to execute the programs regarding microcontroller laboratory. The software here is basically a Keil software from Microvision, Keil Microvision software. We have different versions of these softwares depending on the OS. You can choose from the different versions. For our version which I am using here, I am using Keil Mu Vision 5, which is suiting our particular requirement. So it is basically an open source free software evaluation version which is available. You can easily download it, and the installation procedure is also very easy and it is not at all difficult to install. So on installing, it will basically create a shortcut on the desktop. On this particular icon, I'll just double click to open the software. Once the software is loaded, this is the kind of window we see. If we are using it for the first time, this basic window where I am pointing the mouse pointer would be basically empty. I would not have a file, something called as a data transfer here. I'll basically have a blank screen. Now, how do I use this software is the question. So let me explain what are the basic windows we basically have here. So we have an editor window, whatever this part we have, the plain white part. Okay, so where I have typed the program here. So this is called an editor window. Editor window is nothing but a basic text file that can be created in your Microsoft Office package 2. You can type the program there in a text file and save it later on for the reference, and you can add it directly here. It is basically a simple text file. Okay, this we call it as an editor window. Next, we have a project window where we have the detailed hierarchy of the project that we create till the program that we add to the program project. Okay, so this creates an hierarchy and give you the visual representations of what are the files that are added, what kind of files that have been added. At the bottommost part, we can see a build window where this window will be able to see what is the errors, what is the status of execution, what is the status of debugging and translation status too. All this could be seen here in the build window. Coming to the topmost part of this particular software, we have toolbars. So here these are the basic toolbars. These are, whatever the basic operations we do it here using different tabs are again created in the form of an icons. This is easy access, visual representation. If not, you can go and use it from this particular toolbar also. If you want to know what are each and every functions here, you can just place a mouse cursor there near to it. It will pop up with a detailed translation as such. Okay, so now let us see what is a procedure. Now first of all, we need to understand that my microcontroller understands machine level language only. Okay, we can't basically understand machine level language because it is all combinations of zeros and ones. For writing one program, we would have thousands and millions of zeros and ones combination, which is for us impossible to understand. So what we basically do, we try to incline ourselves to a assembly level language programming or a high level language programming, which is somewhat similar to our normal English, what we use in day-to-day life. So high level language is much more very close to English, wherein our assembly level language program is in terms of opcodes, operational codes, which have predefined meaning. So we have to remember those opcodes to write a program. Using opcodes, we can basically write a program. Now, whenever you see a program, any instruction in that case you take, I am selecting one particular instruction, move at R1, A. Here, the syntax is opcode space operands. Right? Opcode space operands. Move is the operational code. In short, we call it as an opcode. We are doing some operation. What is that operation here? The operation is move. I am doing a move operation on operands. What are those operands at R1 and A? These are the memory and memory locations and registers that I am doing some operation, that is a move operation on these particular operands. So any instruction will have the syntax opcode space operands. The operands can be a single operand instruction, as in this case increment R0, INC R0. Only one operand is there. This is 2 operand instruction, and you might have few 3 operand instruction also. Okay, that is about instruction. So instruction set is again a different topic, so I would be addressing it in the other video. Here, okay, having written the program in assembly language or high level language, we have to translate it for machine level language in order to make our microcontroller execute. So in this process, there are few resultant files, intermittent files that are generated. All of them have to be held together. For that purpose, we are using a term called as project, which holds all the intermittent resultant files together and make them work cohesively. So for that, we need to create project. Go to project, new vision project. You'll just click on it. So now one more window pops up, that is create new project window. You have to give some relevant name to a project. Remember, there is no extension needed to name a project. So I'm just naming a project as intro. You can give any relevant name, no extension here. So select where you want to save. I am selecting my folder. You could create your own folder and save it there. Destination selection is entirely left to you, your choice. So click on save. Once you click on save, it is asking you to select a target. Now what is this target? There are many companies, you can see here, there are many hundreds of companies who are into manufacturing of microcontrollers. See which microcontroller you have for your application. So in our laboratory, we have IC from Atmel. So if you see Atmel, just next to the name, we can see a small plus symbol there. I'll just click on that plus. We can see a drop down of list of ICs. Again, Atmel is manufacturing these many microcontrollers. Again, depending on your application, you would have taken a microcontroller. On the microcontroller, there will be a series number printed. Please note it and type that series number here. We have AT89C551ED2. Okay, you will type that series number. You will, in that the series number is available. Just click and you will be able to note what are the basic characteristics of this particular microcontroller. Okay, what are these basic characteristics of microcontroller is now popped up. So just you can make a note of it just for your understanding. So once you have clicked your target, the IC what you have, click on OK. Now it will ask you to add any existing files. Since I am creating a new file, I am not going for any hierarchying or adding the files which I had already had. So I am clicking on no. So if you are using it for a project purpose, you might need it for hierarchy. So you click on yes. Since now it is purely a practical approach here, a simple demo here, I am clicking on no. So once you clicked on no, you can see project name, intro, whatever I had named, and target one is built. The source group is empty. That means my file is not added yet because I haven't typed the file at all. So I have to now type a file. So go to file here. Okay, a simple text file. Type the program. I am using all the preprocessor directives because that is the best programming practice. For simulation, you can actually skip it, but it is not an advised way. I'm writing a program to add two numbers. I'm taking two numbers, number A and number B. I'm loading those numbers to A and B. Suppose I wanted to add 2, which is moved to A. And also I want to add this second number, that is 3, that is moved to B. H here indicates it is a hexadecimal number and ash here indicates it is an immediate data. So after that, let me say add A comma B. A and B are added and the result is stored in accumulator. That's it. I don't want to do anything else. I'll just type end. So here ORG30, ORG00, OSGem30, ORG30 and end are called pre-processor directives. Move and add are opcodes. A and B are operands. 2 and 3 are immediate data. Okay, so I have typed the file, whatever program it is, you just type it. Again, I'm telling you, it is not case sensitive. You need not type it in capital letter always. You need not type it in small letter. It's fine. So after you have typed it, okay, you will save the file. Okay, you will click on save and you will save the file. You can give any name. You can give the same name or you can give any other name. It is again completely left to you. I suggest giving the same name so it will be easy for us to track it. .asm. Why .asm? Because it is an assembly language program. So I'll have to give the extension for the file. I'll repeat again. No extension needed for project creation. Extension .asm is needed for program. Again, if you're writing the program in C language, you can give intro.c or some name.c. Here I'm writing the program in assembly, so I'm writing it as intro.asm. So once you have named the file, click on save. As soon as you click, please note what are the changes that is happening in your program. You can note predefined words are highlighted in blue. The registers and memories are highlighted in green. User-defined data are in red. Okay. Even though I have typed the program and saved it as .asm, I have not created the link between the program and the target. So I have to link them both now. How do I do it? Right click on source group, add existing file because I have already saved the file. So it is an existing file. Add existing file to source group. What is the file type? The file type was ASM. I'll select ASM. So we'll have a list of programs. So intro.asm is what I had typed. Intro.asm, add and close. So you can see here our program is added to source group and source group entered to target. Target is entered, linked to intro. This is the process of creating a project. Once you have created a project, we have to check for the errors, translate it successfully into machine level language if there are no errors and warnings. After that, you can go to debug to check for the result. Okay, just to show an example, I am creating one error here. Okay, let me say the error instead of B, sorry, let me type, while typing I had missed B, just assume. Okay, so can you people see a translate symbol here? If people could note a translate symbol. Okay, click on translate. Okay, once you click on translate in the build window, what you can see here is there is a syntax error. If this program is 7-line program, it's fine. It's completely fine. You can search where is the error. If you have hundreds of lines of program, then it is difficult for you to sit and search which line has an error. So here you can see intro.asm in brackets 5, which indicate 5th line is having an error. So go to 5th line and correct that particular error. Save again and translate. You have to keep doing it repetitively until you get this particular status successfully. That is 0 warnings and 0 errors. Once you have got this, it indicates that your assembly language program is successfully translated to machine language. Now machine level language program I have to make it behave like a hardware that basically I have. That hardware is 8051. So basically you can go for build. Okay, you people can just click on build. Once you had built, go to debug. You have debug here, or you can go for debug, start and stop debug. This is also possible, or you can go for this. Just click on OK. Since I am using an evaluation version, we have a limitation that the code memory could be maximum of 2 kilobytes. So anyhow, this is a small program, so it will be well within the limit. So click on OK. So on debugging, this is basically the debug windows. I'll explain what are these windows. Again, this is a editor window. This is register window. This is basically the disassembly window. You can see what are the instructions disassembled in the form of operational address and codes. Okay. Next, you could see the command window. And you could also see a memory window here. You could type whichever address you want. Say I want to go to 8000H. I'll just type it. You can see a memory stack. Anyways, for this program, I don't need a memory at all. So coming to the editor window, we can see a small pointers here, a small arrow marks. This is representation of program counter which points to the instruction which has to be executed next. Okay. So let us do a step-by-step process here as an initial program. So you can run the program at once entirely. You can see run. So all program would be executed at once and you will be getting a final result. Or you can go for step-by-step execution. Since it is a first program, let us do a step-by-step execution. So I'll click on step into once. You can note sjump that is executed. So it is marked in green. And PC is pointing to the next instruction. Parallelly, keep seeing what are the changes that can happen in register window. Now, you can see A and B both are 0 now. I'll step into again. A is equal to 2 is executed. So, you can see in register window A is equal to 2 loaded. Next, PC is pointing to B is equal to 3. B is loaded with 3. Again, I'll step into both are added and result 5 is stored in accumulator. Even after that, if you keep on clicking step into, there is no program, there is no operation. So you can see a list of NOPs because I haven't written anything. That is the end of my program. As soon as you say end, it is a list of no operations coming into picture. This is the way we see the result. Sometimes the result can also be happening in the memory window. That depends on the program that we have written. So this is how once you have seen, you can please stop the debugging. Okay, so again you will come back to the project window. So this is how we basically do the program execution. This is the step by step. Hopefully you people have gathered basic knowledge on using the Keil software. So hereafter we can proceed with the programming. Okay, thank you so much.